You can tell that a relationship is proportional by looking at its graph if it satisfies two criteria. Number one, there must be a constant of proportionality. There must be a k. And number two, the line must pass through the origin. Okay, this is origin. The origin, of course, is at the point 0, 0. It is the intersection of the x and the y axis. So we already know that the equation of a proportion. When looking at a graph of a relationship, you can tell if it is a proportional relationship if it satisfies two criteria. Number one, there must be a constant of proportionality. There must be a k. And number two, the line must pass through the origin. This blank right here is origin. The origin is the point 0, 0. It is the intersection of the x and the y axis. So we already know that a relationship is proportional. If it is proportional, we can use this equation, y equals kx, where k is the constant of proportionality. To find k, we would take our y values and divide by the x values. So here's an example of a proportional relationship. If this is the origin right here, the line is a straight line that passes through the origin. Number two, or not number two, in this second example, this is not proportional because right here is the origin and this line does not pass through the origin. Okay, number one right here, is this a proportional relationship? Okay, if I were to draw a line through these dots right here, does it pass through the origin? Here's the origin right here. Is this line passing through the origin? No, right? So this is not a proportional relationship. The explanation is the line does not pass through the origin. So maybe add a text box in there and say the line does not pass through the origin. Number two, is the relationship proportional? Okay, if I use my little shape tool here and insert line, you can see that if I connect these dots, it is a straight line that passes through the origin. So is the relationship proportional? I would say yes. And my explanation would be it is a straight line that passes through the origin. So let's write the equation for this relationship. Remember, the equation for a proportional relationship is y equals kx. Okay, now these dots right here tell me the ordered pairs. And so this dot right here is the point 140, right? I would go from the origin, I would go right 1 and up 40, right? Because that's the point right here. So 1, comma 40. That is a point. What about this point right here? This point is at 1.5, 60, right? I know it's 1.5 because if I go right, I'm in between 1 and 2. And so that would be 1.5 or 1.5. And then I would go up 60. I know it's 60 because it's between 40 and 80. And between 40 and 80 is 60. Okay, this point right here is the point 3, 120, right? I would go right 3 and up 120. So that's the point 3, 120. And this point is the point 4, 160. I would go from the origin, I would go right 4 and up 160. Okay, now remember, in an ordered pair, the first number listed is your x value, and that is your y value. And so if I take all of my y's and divide them by my x's, I will get my k, my constant of proportionality. All right, so here I got 40 over 1, 40 over 1. My y value over my x value, 40 over 1 is 40. Here I have 60 over 1.5. If I take 60 and divide by 1.5, I get 40. Here I have, in this point, 120 over 3. 120 over 3 is 40. And then I have 160 over 4. So I get 40. So as you can tell, I got 40 each time. That is my k, my constant of proportionality. And so that is the number I can put in for k. So this equation is y equals 40x. Y equals 40x, which is telling me that my distance is 40 times the number of hours. And so after 2 hours, right, after 2 hours, if I put that in for x, 40 times 2 is 80, right? So after 2 hours, I would travel 80 miles. And if I try to put that point on the graph, it should still be on the line. So 2 hours, and I go up to 80. Yep, it's right there on the line. Okay, number 3 here. Is this a proportional relationship? Okay, if I connect these dots with a straight line, it's a straight line that goes through the origin. So yes, it is a proportional relationship. It is proportional. What is the explanation? It's a straight line that goes through the origin. So let's write the equation here. To write the equation, let's first write the ordered pairs. So from the origin, I would go right 2, up 10. So that first point is 2, 10. Then I would go right 4 and up 20. So I have the point 4, 20. Okay, then this third point, I would go right 6 and up 30. So this is the point 6, 30. Okay, then the fourth point, I would go right 8 and up 40. Right 8, up 40. So that's the point 8, 40. And so like I did in the previous problem, I'll take my y values and divide them by the x values. And so I have 10 over 2, 20 over 4, 30 over 6, 40 over 8. That is all 5, right? K would be 5. And so the equation is y equals 5x. Okay, what will be the distance after 12 seconds? Well, after 12 seconds, if I put 12 in for x, 5 times 12 is 60. And so I would expect that on this time interval on the x-axis, if I had 12, say, right here, I would go up to 60, and it would be on the line. Number 4, is this relationship proportional? Okay, if I connect these with a straight line, okay, does the line pass through the origin? No, it doesn't, right? Right here is the origin, and so no, this is not a proportional relationship. What's the explanation? It does not pass through the origin. That is the explanation. Okay, number 5, some hikers had an average speed of 2 miles per hour. Draw a graph to show how the distance is related to time. Plot at least 4 points. So they're traveling 2 miles per hour. Keep that in mind. 2 miles per hour. 2 miles per hour. So over here, my drawing tool, I'm going to change my thickness to 8. That way I can make some dots. So this would be like 1, right? 1, 2, this would be 3 hours and so on. So if they're traveling 2 miles per hour, here is 4 miles. And so halfway between 0 and 4 would be 2. So that would be 2 right there. So they travel 2 miles in 1 hour. So there's a dot right there. That's where they're at. And then if they're going 2 miles per hour, after 2 hours, they would be at 4 miles. After 3 hours, they would be at 6 miles. After 4 hours, they would be at 8 miles. And so as you can see here, if I go shape and then insert line from the origin, I can connect the dots with a straight line. Okay, now I can answer some questions. Write the equation used to represent the data in the graph below, or data in the graph above. Well, notice my points here are 1, 2, right 1 and up 2. Right 1, up 2. So I have the point 1, 2. Then I have the point 2, 4. Then I have the point 3, 6. Then I have the point 4, 8. Okay, so to find the constant rate of change, I would take my y values and divide them by my x values. So 2 divided by 1 is 2. 4 divided by 2 is 2. 6 divided by 3 is 2. And 8 divided by 4 is 2. So my constant proportionality is 2. So the equation would be y equals 2x, right? I'm putting 2 in for x. So how far do they travel after 11 hours? Well, if I put 11 in for x right there, for the number of hours, 2 times 11 is 22. So they traveled 22 miles. 22 miles. Number 6, does this relationship represent a proportional relationship? It's a straight line. Does it go through the origin? Looks like it does, right? So yes, because it goes through the origin. And so what is the constant of proportionality? Look at their ordered pairs here. This is 2, I'll tell you 2, 7, right? It's not quite to 8. So 2, 7. Okay, this is the point 4, 14, right? This right here would be 12. And this is between 12 and 16, which would be 14. So 4, 14. 4 comma 14. Okay, this point is at 6. If this is 16, that's 24. That means this is 20. And this point is directly above 20. That'd be 21. So 6 comma 21 is that ordered pair. And then you have this point, which is at 8. 8 looks like that is 28, right? That's 28 right here, which is halfway between 24 and 32. So 8 comma 28, I believe that is. All right, so that gives you your x values and your y values, almost like a table, right? So take your y's and divide them by your x's to get k, right? K is y divided by x. So 7 divided by 2, 14 divided by 4, 21 divided by 6, and 28 divided by 8, and that would give you your k. And so then you could write k equals and put it on the line.